Hello. This is a short presentation on rainwater harvesting. So what I'm going to cover is what is rainwater harvesting, why is it important, and then look at some of the rules, some of the key considerations to think about when you're designing a rainwater harvesting system, and then finish off with some resources and references and some tools. So, what is rainwater harvesting? Rainwater harvesting is also called rainwater collection, um, and it is basically the capture of rain from surfaces in tanks for human use. And they can be very simple, something as simple as a barrel catching water off a roof, or they can be very complex, so very large systems with tanks, filtration, etc. The particular picture here is a picture of a Bawari, which is a traditional rainwater harvesting system in India, and you can see many of those in dry parts of India. So what is rainwater harvesting in terms of its components? Usually there'll always be a collection surface where you capture the runoff from rain. And usually that runoff may have dust and leaves, so there'll be a first flush filter that removes that dirt. It will then be directed to a tank where the rainwater is stored. If you're going to use that water for drinking purposes, there may be additional filters, and then it'll be used internally. So, for instance, for drinking or flushing toilets, etc. Alternatively, it may be used externally to wash cars, for irrigation, for instance. So why they're important? One of the reasons why they're important is that many areas globally are considered water scarce. They have very limited water supplies, and so it's very important to be careful with water and to collect water where you can. And you can see here that a lot of Southern Africa, Northern Africa, Australia, parts of the US, a lot of Asia, and parts of Europe would be considered highly water scarce in terms of this particular graph and map. Another reason why it's important is that increasingly in some areas, water supplies from water utilities, from municipalities are becoming irregular. For a number of reasons, old networks, limited water supplies, power interruptions are leading to interruptions at houses, schools, etc. So this particular graph shows that there are certain provinces, this is in South Africa, that have increasingly reduced reliability in terms of water. Another key factor is the cost of water. And when you think about the cost of water, it's not just the water tariffs that you pay your municipality in terms of the amount per kiloliter. It also often includes the water that you flush down the toilet. And so there's a sewage tariff as well. And when you add the two of those, you get fairly substantial tariffs, and that can add up over a month. So that's another reason why people look at rainwater harvesting. So what are the key benefits? From a municipal point of view, key benefit is that you reduce the pressure on municipal systems. From a house or building point of view, building owner point of view, business owner point of view, is that you increase the resilience of the building. You don't have to close the building if there's a water interruption. You can carry on because you've got your own supply. Reduced operating costs and environmental. If you think about the distances that water have to be pumped in municipal and water utility systems, they have to be treated. There's a whole range of impacts associated with very large water infrastructure systems, and a lot of those you avoid by having a rainwater harvesting system on your own site. So if we are looking at the design and planning of a rainwater harvesting system, what are some of the rules we can think about? The very first one is understanding rainfall patterns, and you can get data on rainfall from your local weather bureau. You can find a lot of this information on the internet, and a number of quite important things that you need to look at once you get 12 months worth of data. The very first thing is it's important to think about the total annual rainfall. Is it 600 millimeters? Is it 700 millimeters? That'll give you an idea of the capacity of your system and the variability. Is it always around 600, or does it vary from 400 to 800 millimeters? So is there big variability that gives you a picture of the risk? When does most rainfall occur? So what parts of the year? So when is the wet season? Is it November, December, January, or is it June, July, August? And that's important because what you're trying to do, the rainwater harvesting system, is collect water when it's needed. So if your main rainfall falls when the building is full and has many people in it, that works well because you can then use that water directly in your building. How regular is rainfall through the year? Again, does it fall regularly all the way through the year? And if it does, that minimizes the need for a very large catchment area and very large tanks. And then the very last one, which is quite an important one, is what's the length of the dry period? Because if you are going off grid, you're going to have a system that will take you through that period. And you'll need to have, the longer the dry period is, the bigger the surfaces and rainwater tank volumes you're going to need. So let's have a look at rule number 2. It depends what you're going to use your rainwater for. If you're going to be self-sufficient, you need a particular system. If it's just to irrigate plants, again, another type of system is suitable. If it's for flushing toilets, again, you can work that out and you can provide a system for that. And if it's for costs, again, then you're going to look quite carefully at the capital costs of your rainwater harvesting system and design a system that has a good return on investment. Very important to understand quantities, and you can get this data from the municipality. You can look at your water bills over 12 months and calculate how many liters you use. Alternatively, you can model it, and there's some very simple modeling tools, calculations you can do to get a good estimate on consumption requirements, and I'll come back to this at the end. You can also look at benchmarks. So there are some very simple benchmarks from the WHO, very minimal amounts, 30 liters per person per day, particular dry areas and emergency situations. Another example is 80 liters per person per day, which is seen as best practice in the UK's Code on Sustainable Homes. So rule number 3, identify catchment areas. So if you're starting to think about the design of your rainwater harvesting system, very important to identify potential collection surfaces. So this is a school. The dotted line shows the perimeter, and then you have the buildings in the hard lines. You've got a sports grounds, and then you've got larger running tracks and rugby fields, etc. So start with the roofs, add those up, see what sort of area you get, and then you can move through to things like shelters. If there's car parking shelters, carports, you can use those. Much better because they're cleaner and they're already high up, so you've got some gravity that you can use to fill your rainwater tanks. If that isn't sufficient, then start looking at clean hard surfaces, things like sports courts, etc. Generally avoid things like car parking areas because of the oil, but if it is for something like irrigation, you can also put in an oil filter for that. And lastly, if you really need to, you can use hard surfaces and large sports grounds, but you get a much lower runoff from those type of surfaces. So next thing is think about runoff losses. All of the different surfaces that you can use, collection surfaces, have different runoff coefficients. So if you've got a very solid surface, it's got a good slope on it, so tiles, galvanized sheeting, you would have runoff coefficient of 0.9. And what that means is that you'd only lose about 10% from evaporation, from losses of that water flowing into your gutters and being collected. Other types of surfaces, so concrete, certainly things like soil, ground cover, you have much lower runoff. So you aim for materials with high runoff coefficiency so that you get most of the runoff flowing into your rainwater tanks. Include filters, very important. I said this at the beginning. Really make sure that your water is clean. It has to be good quality, and the 2 or 3 very simple filters that you can use for this. One's called a leaf eater, and it basically just gets rid of things like leaves and dust, and that there's a grill in the water, takes that detritus and gets rid of it before it goes into rainwater tanks. Another system is called a first flush device. This is more effective for things like dust. So the way this works is that it fills up a predefined amount of water, so all the dust gets directed and dirty water gets directed here, and then by the time it's clean, it then goes into the main rainwater tank, and you can get rid of that water later. So estimate the total capacity of your roof. This is a very simple calculation. You take your local precipitation, you take your catchment area, your runoff coefficient, and that will give you the total capacity that you will be able to harvest. So here we can take 600 millimeters, 0.6 times 100 meters squared of roof area, times 0.9, which is our runoff coefficient if it's a metal roof, and we then have a figure of 54 cubic meters or 54,000 liters, and that's what we can harvest over a full year. Identify the pinch points. So it's important now to start thinking in a bit more detail about what's going to happen over the year. And we talked about the dry period, the dry season. And the way you can calculate what you need to do during this period is look at your daily consumption. So in this particular case, it's 160 liters per day. And then you can look at the length of your dry season. So it might be something like 4 months, which would be 120 days. You then multiply 160 by 120, you get 19,200 liters of water. That's the minimum amount of water that you need to have stored at the beginning of your dry season in order to carry you through that dry season. So that's quite an important measure, particularly if you're going off-grid for water. Model to test and refine. This is where you use a slightly more sophisticated tool and allows you to actually track the volumes of water in a rainwater tank or sets of rainwater tanks over time. And you can see here rainfall at the bottom and what then happens to the volumes of water in the tank. And you can see as you get quite heavy rainfall, the tanks go up quite quickly. and then you hit the dry season. It goes down steadily as people consume that water, and then you reach the end of the dry season, and you get your first rainfall, and then it starts building up again for the next year. So some quite important things here. First of all, this graph shows that the system is adequate because there is water in the rainwater harvesting tanks throughout the year. So that's a good sign. It shows the maximum amount of volume stored. So this figure here you can take off, and that can give you the size of your rainwater tanks that you're going to need. And then the other really important one is this pinch point here, where it shows you the minimum amount of water that's left in a rainwater tank. And that also is very important to understand, because that's the point at which you may run out of water. So you need to think about that in your design. In this case, it doesn't happen. The rainfall picks up and the volumes increase quite quickly. So while you're thinking about that dry period, you need to think about a contingency. And what is your contingency? How many days of water do you need to have stored in case rainfall is late, in case it's a bit erratic at the end of a dry season? And so what this shows is, it says this particular example goes for about a 15-day contingency. So it enables you to last a bit longer at the lowest point. And so you can build in a percentage, you can build in a particular volume or levels of consumption, so that you build in insurance to make sure that you'll always have enough water from your rainwater harvesting system. Very important, particularly if you're going off grid, because if you run out of water, you then have to do something like get tanks and bring that water in. So very important calculations here to test and think through. Provide for monitoring. Very important that your building users understand where water is in the rainwater harvesting tanks. Can be something as simple as this, a float with a meter that shows whether it is, or you can get more sophisticated systems that are linked, for instance, to cell phones, etc. But it's to ensure that they understand where the rainwater levels are within tanks, and so can slow down consumption if they have to in, for instance, the dry season. Develop the business case, very important. Someone's going to have to pay for your rainwater harvesting system. So do the calculations, work out the capital costs, work out the operational costs, look at tariffs, both for consumption as well as for sewerage, because you can add those together to get the overall amount. Make sure that you look at normal tariffs, and if drought tariffs, which can be twice, 3 times as much as normal tariffs, look at those tariffs, do a calculation that shows the payback periods, that shows the return on investment, and use that in your discussion with the people who make decisions about financing a rainwater harvesting system. The second part, which is perhaps more important, is to talk through the impacts, to understand the impacts of an interruption of water supply. So if you have a municipal system and you run out of water, what does that mean? Does it mean you send people home, you close a school, you close a factory, and how much is that going to cost? You've got to pay salaries, you've got to, you may lose customers because there's no services or products provided. What does that mean for a business? So very important, and the bigger picture is, if you look at a school, for instance, if you close a school down for 2 or 3 weeks or months around exam period, there are major impacts that could lead to exam failures, higher unemployment rates, etc. So these are really important to talk through. So the cost of a rainwater harvesting system may actually seem very low once these are considered. So it's worth talking these through with your key stakeholders at a building. So the last couple of things I'm going to talk about is some of the modeling tools. So this is a very simple Excel-based tool that you can use to calculate water use in a building, and you can plug in occupancy, your schedule, and then the different water fittings, and it'll give you a very clear amount of water that will be used per day and per person. This is a very simple tool that can be used for schools, but also for other buildings. And what it does is it shows the amount of rainwater harvested versus the amount of water that's used, and it enables you to see the pinch points. So again, here you can see in this table that there's a couple of orange months where consumption exceeds production, and so you can redesign your system if you need to try and get that rainwater harvesting system bigger to enable you to avoid those pinch points. The last one is a more sophisticated tool. It's the modeling tool that enables you to track water consumption in rainwater tanks over a full year and generate these sorts of graphs. It is more complex and it does require daily precipitation data, which sometimes is not easy to get. So if you've got the data, it's very powerful, it's a very useful tool, but only if you can get that data. Thank you, and there will be more resources available on the Substack form.